1 stack of hardwood logs, 7 mushroom species. A food production system that fruits across spring, summer, and fall, lasts 5 to 7 years per log, and recycles its own waste into the next generation of production. This is a self-sustaining design. Most mushroom growers cultivate a single species indoors with recurring substrate costs, monthly electricity bills, and continuous environmental management. This system operates outdoors in a shaded corner of a property with no electricity, no climate control, and no recurring input costs after the logs are inoculated. Each species was selected for a specific reason: what wood it prefers when it fruits, how fast it decomposes the log, and what role it plays in the cycle that keeps the system running without outside inputs. The focus on species and function is deliberate. 7 species means 7 overlapping harvest windows across 3 seasons and multiple years from the same footprint. This video covers all 7, why each one was chosen, and how they connect into a loop that feeds itself. The 6th species is the one that closes it. A stack of shiitake logs fruits in spring and fall. For the rest of the year, it sits dormant. Productive, but not a system. 7 species distributed across the same stack transform that seasonal output into continuous production across 3 seasons and multiple years from a single footprint. Shiitake anchors part of that cycle. Different species decompose wood at different rates. That variation is the design principle the entire system runs on. Oyster mushrooms colonize aggressively and fruit within 6 to 12 months, but exhaust their logs in 2 to 3 years. Shiitake colonizes more slowly and produces for 4 to 7 years. Running both on the same stack means the grower harvests fast early production from oyster logs, while shiitake builds toward its longer cycle underneath. As one species finishes, another is entering its peak. Oyster and shiitake balance short-term and long-term yields. Different species prefer different woods. Shiitake thrives on oak. Oyster colonizes maple and poplar. Lion's mane favors beech. Those preferences mean 7 species occupy different logs within the same stack without competing for the same substrate. Each species has its own lane. Species succession adds a final layer. A log partially decomposed by shiitake over 5 years becomes ideal habitat for a ground-level species that colonizes softened wood. The output of one species becomes the input for the next. 1 stack footprint, 7 species. Production across 3 seasons and multiple years. That is a system, not a crop. Succession closes the loop. The stack is not a random pile of inoculated logs. It is a designed layout where log type, diameter, and position are matched to each species' biological requirements. Understanding the layout before learning the species is what separates a collection of logs from a functioning production system. This is a designed layout. Log diameter determines colonization speed and productive lifespan. Smaller logs 3 to 5 inches in diameter colonize faster and produce their first harvest sooner. Larger logs 6 to 10 inches take longer to colonize but produce for more years. The stack contains both. Small diameter logs deliver fast early harvests. Large diameter logs anchor long-term production. Staggered timelines from the same inoculation day provide reliability. Vertical position matters. Upright totems, logs stacked vertically end-to-end with the bottom buried slightly in soil, suit species that fruit from the sides of standing wood. Horizontal crib stacks arranged in alternating layers like a log cabin suit species that fruit from top and side surfaces. Ground contact logs and stumps partially buried in soil suit the large fruiting species that produce from the base. Wood chips spread across the ground beneath and around the stack suit the final species that operates at soil level. Vertical placement alters fruiting behavior. The entire stack occupies a shaded area of roughly 50 to 100 square feet. One large hardwood tree felled in late winter produces enough logs of varying diameter to build the complete system. All 7 species are inoculated during the same late winter or early spring window and placed into their designated positions on the same day. Shade, moisture, and airflow are the only environmental requirements. A forest edge, a tree line, or the north side of a building provides everything the system needs without a single piece of equipment. The first 2 species carry the majority of the system's production volume. They are the most reliable, most proven log cultivation species on Earth, and they anchor the stack's output across its entire productive life. Shiitake is the gold standard. Lentinula edodes colonizes oak with exceptional reliability and fruits primarily in spring and fall, triggered by rain events and temperature shifts. A single well-managed shiitake log 4 to 6 inches in diameter produces 1 to 2 pounds of mushrooms per year across 2 to 4 natural fruiting cycles. That production continues for 4 to 7 years per log. The texture is dense, meaty, and measurably different from indoor-grown shiitake. Log-grown commands $12 to $25 per pound at retail, a consistent premium that chefs and specialty buyers pay without hesitation. Oyster mushrooms are the fast start. Pleurotus austriatus colonizes softer hardwoods, poplar, maple, and sweet gum aggressively and delivers first fruit within 6 to 12 months of inoculation. Fruiting spans spring through fall with a broader temperature tolerance than shiitake. Oyster logs produce heavily during their active years but exhaust faster, 2 to 4 years per log. Retail pricing sits at $8 to $14 per pound, with strong demand at farmers markets and from restaurant buyers. Together, these two species cover the widest harvest window and the broadest temperature range in the stack. Shiitake on oak anchors, long-term production measured in years. Oyster on poplar and maple delivers fast, heavy early returns. Different logs, different timelines. No competition between them for the same substrate. The next two species are not volume producers. They are value producers, filling specific harvest windows with product that sells at the top of the price range and adding market diversity that single-species growers cannot offer. Lion's mane is one of the most visually striking mushrooms a log grower can produce. Hericium erinaceus fruits in large, shaggy white clusters from beech, maple, and oak logs during late summer and early fall. That harvest window fills the gap between oyster's spring flush and shiitake's autumn peak. Log-grown lion's mane commands $14 to $25 per pound at retail. The medicinal supplement market adds a secondary buyer channel driven by growing consumer demand for lion's mane extract as a cognitive health product. Each log produces for 3 to 5 years. Nameko is the species most American growers have never encountered. Pholiota nameko is a Japanese culinary mushroom prized for its amber color, gelatinous cap coating, and rich flavor in soups and sauces. It fruits in cool, wet conditions during fall and into early winter, extending the stack's harvest season weeks or months beyond what shiitake and oyster cover. Nameko prefers beech and oak. It sells for $12 to $20 per pound where available, and in most local markets it is available almost nowhere. That scarcity is the competitive advantage. A grower offering fresh Nameko at a farmer's market or to a restaurant chef is offering a product that essentially no one else in the area provides. Lion's mane fills the late summer gap. Nameko extends production into early winter. Together, they add premium pricing and market differentiation that transform the stack from a two-species operation into something significantly more valuable per harvest day. The fifth and sixth species do not fruit from standard log-sized rounds. They produce from stumps and large-diameter base logs, the pieces most growers leave behind in the woods or burn in a slash pile. On this stack, nothing from the original tree goes unused. Maitake, also known as hen-of-the-woods, is one of the most prized wild mushrooms in North America and one of the most difficult to produce reliably through indoor cultivation. Grifola frondosa fruits from oak stumps and large log sections partially buried in soil. Under optimal conditions, a single stump produces massive rosettes weighing 5 to 50 pounds or more per fruiting event. That is not a typo. One stump, one flush. Potentially 50 pounds. Maitake fruits in fall, sells for $15 to $30 per pound, and continues producing from the same stump for 5 to 8 years. Burying the butt log or leaving the stump in the ground after felling and inoculating it with Maitake spawn turns the heaviest, least portable piece of the tree into the single highest yield production unit in the entire system. Chicken of the woods occupies the remaining large diameter logs. Latoporus sulphureus produces bright orange shelf formations from oak and cherry in summer and early fall. The texture mimics shredded chicken closely enough that vegetarian and vegan markets seek it actively. Pricing runs $15 to $25 per pound. Each log or stump produces for 3 to 6 years. Both species use the pieces of the felled tree that the other 5 cannot efficiently colonize. The small logs go to Shiitake, Oyster, lion's mane, and Nameko. The stumps and butt logs go to Maitake and chicken of the woods. Every piece of the tree has a species assigned to it. Nothing is wasted. The 7th species is the one promised at the beginning of this video. It is the species that turns a productive log stack into a self-sustaining closed loop where nothing leaves and everything feeds the next stage. Winecap, also known as king Stropharia, Stropharia rugoso annulata, does not grow on intact logs. It colonizes wood chips, mulch, straw, and partially decomposed wood. That substrate description matches exactly what the other 6 species leave behind when their logs reach the end of productive life. As Shiitake, Oyster, lion's mane, and Nameko logs exhaust their output over 3 to 7 years, the softened, partially decomposed wood is chipped or broken apart by hand and spread as a mulch bed around and beneath the active stack. Winecap mycelium colonizes this spent material and produces large burgundy-capped mushrooms through spring and summer. Mild, earthy flavor with a firm texture. Sells for $10 to $20 per pound at farmers markets and direct to restaurants. The fruiting adds an additional harvest window from material that every other growing system would treat as waste. The deeper function is what makes winecap irreplaceable in this system. As it fruits from the spent log material, it continues breaking down the wood into rich, dark compost. That compost feeds the soil around the stack. That soil feeds the trees growing nearby. Those trees eventually produce the next generation of hardwood logs. The waste stream of the system becomes the input for its final species. The output of that final species becomes the fertility that grows the next cycle of logs. No material leaves. Nothing is purchased to replace what was consumed. The loop closes. The complete cycle runs on a single principle. Nothing leaves the system, and everything feeds the next stage. In years 1 and 2, oyster logs fruit first with their fast colonization. Shiitake logs begin producing. Lion's mane and Nameko colonize quietly in the background. Winecap beds established from initial wood chips produce their first ground-level harvest. By years 2 through 4, all 6 log species are producing across spring through early winter. Maitake rosettes emerge from buried stumps in fall. Chicken of the woods shelves appear from large diameter logs in summer. The stack is generating food across 3 full seasons from 7 overlapping harvest windows. Years 3 through 5, the first oyster logs exhaust their productive life. The softened wood is chipped and added to the winecap beds. Winecap production expands as its substrate supply grows. New logs inoculated annually with shiitake and oyster replace the expiring ones. The rolling cycle is now established. By years 5 through 7, shiitake logs from the original inoculation are still producing. Decomposed winecap beds have become rich compost applied to the surrounding soil. That soil feeds the woodland that produces the next generation of logs. Annual maintenance is measured in hours, not weeks. Inoculate 10 to 20 new logs each winter to replace expiring stock. Move spent logs to chip beds. Harvest across seasons. Water during dry spells. The risks are manageable and predictable. Logs drying out completely kills mycelium. Competing fungi colonize improperly stored or too old wood before target species establish. Slugs damage winecap and Maitake fruiting bodies at ground level. Basic shade, fresh logs, proper wax sealing, and occasional watering address each of these without equipment or expense. 1 hardwood tree, 7 bags of plug spawn, a drill and a hammer. That is the year 1 investment. Fell or source 1 large hardwood tree in late winter. Cut into logs of varying diameter. Inoculate each log with the species matched to its wood type and size. Stack in shade. Lay an initial winecap bed from wood chips around the base. Total cost, $75 to $200 in spawn plus the wood. In year 2, The first oyster and winecap harvests arrive. Other species are colonizing. In year 3, full multi-species production runs across 3 seasons. The system is generating food and recycling its own waste simultaneously. Add 10 to 20 new logs each winter to maintain rolling production as older logs expire. Total ongoing annual cost, $30 to $80 in spawn. Everything else comes from the property itself. 1 stack of logs, 7 species. A food system that produces for years, fruits across 3 seasons, and recycles its own waste into the next harvest. The entire input is 1 tree and an afternoon. Subscribe for more self-sustaining food production strategies. Drop a comment and tell us which of the 7 species you would start with first.